Hello, everyone. Thank you for joining us today for this webinar titled Case Study, How MRAS Uses Digital Tools to Cut Waste, Cycle Time, and Boost First-Time Yield for CFRP Parts. It is brought to you by Composites World and presented by Plataine and Middle River Aerostructure Systems. My name is Ginger Gardner, and I'm Senior Editor at Composites World. Mitchell Smith, Composites and Sustainability Technology Leader at MRAS, which was acquired by ST Engineering in 2019, has been tasked with improving sustainability for a 1.4 million square foot facility that is 100% composites and bonding, with 90 plus years of production experience. He will discuss lessons learned and a practical implement as you can strategy for combining automation, digital tools, and AI to achieve sustainability goals. MRAS achievements so far include 80% reduction in CFRP material waste, 96% first-time rate yield for composite nacelle structures manufactured in excess of rate 60, and reduced cycle times, for example, 4 hours to 12 minutes, across various operations, including kitting, layup, and preforming. One part of the MRAS strategy is Plataine digital tools. Plataine will discuss these tools and how they can be used to digitally track and optimize production planning, materials, mold tools, machines, and other resources to meet increased rates and cost pressures while enabling flexibility. Plataine will walk through implementations such as more effective management of time-sensitive materials such as prepreg throughout production, from the receiving dock to digital twins and databases. Our presenters today are Avner Ben-Bassat, President and CEO of Plataine, and Mitchell Smith, Composites Technology and Sustainability Leader for MRAS. Plataine is a provider of AI-based and industrial Internet of Things optimization solutions for advanced manufacturing. As President and CEO of Plataine, Avner leads the company's product vision and global business strategy. Plataine solutions are used by leading manufacturers worldwide. Avner has been invited to speak at over 40 major composites and aerospace-related conferences globally in the past 5 years. He holds an MBA from Duke University and a bachelor's degree in mathematics and computer sciences from Tel Aviv University. Mitchell Smith is the Composites Technology and Sustainability Leader at MRAS. He has over 30 years of experience over a broad range of markets, materials, and processes. He specializes in composite materials design and manufacturing and leads a team of engineers that develops new technologies for aerospace structures, supporting engines, nacelles, and aerostructures. He holds a bachelor's degree in mechanical engineering from Boston University. Before we begin, I'd like to remind you to please submit your questions by typing them into the question pane on the control panel at the right of your screen. We will get to those during our Q&A session at the end of this presentation. And now I'm going to hand it over to Avner and Mitch.
Hi, Ginger. Good morning and good afternoon, everyone here on the call. Again, Avner Ben-Bassat here. It's a pleasure being here. And Ginger, thanks again for the kind introduction. Our plan for today is really, briefly introduce the topics we want to talk about. I'll start. Let's talk more broadly about how we would like to implement digital manufacturing, share some of the challenges that we're seeing, the vision and lessons learned, and really quickly turn it over to Mitch to talk about the Middle River story. I think it's a fascinating one, really thought through and gradually deployed, and Mitch will get into these details. So without further ado, let's jump in. Just a word about us. Again, as Ginger had said, we're a software company. We specialize in applications for manufacturing, really coming as a new layer of intelligence over the current landscape. Systems used today globally, from OEM level down to the smallest suppliers, really present in all major supply chains today. I think perhaps more interesting and relevant to our call today is the ecosystem of partners that we are operating and very proud to be part of. Vendors like SAP and Siemens, whom we complement with our applications, being very proud part of technology research organizations like the British National Composite Center, Airbus's Composites Technology Center, and the AMRC with Boeing, again out of the UK. All of these are really hubs of technology and innovation around composites, and we're very proud to be part of those in that exchange. And of course, equipment providers, really market leaders such as Vertec and Eastman, being part of this story, and together with SAP of Middle River's digital deployment. We're proud to have awards and recognition by the industry, cybersecurity certification, and alike. Now, when we work in the industry today, and we're talking to hundreds of composites fabricators globally, we see, a broad range of challenges that they're dealing with. And, the industry is ramping up. We see a lot of turmoil from a macroeconomic and a geopolitical standpoint. But at the end of the day, it's hard enough to run a factory and it's hard enough to ramp up. But then you have your supply chain disruptions, unpredictable demand, big issues of hiring back workforce and training them. And then, of course, all the changes we have day to day from regulation, cost pressures, and so forth. So this presents a very big challenge to everyone in the industry, everyone in the supply chain, and frankly, us included. But we see a lot of ways where the technology can help, and we'll talk about some of those today. And really, when we go out there, what do we see? We see factories running, right? They're making parts. But we also see the team working very hard to deal with a lot of stuff. All the complexities of manufacturing parts, machines, tools, materials, etc. But the systems are poorly connected, and there's a lot of paperwork in the process. And at the end of the day, every shop level staff member makes 10, 20 decisions a day. So if you're running a factory with 100 or 1,000 people, you're looking at thousands of little decisions that are made really with poor visibility and limited data. And that's the reality that we see. So again, a lot of opportunity for improvement in terms of waste, productivity, and quality. And Mitch will definitely talk about how Middle River achieved those. Our vision and what we see is happening is the ability to connect the dots, connect data, get data from all the systems and all the sensors, and put it to play. Bring alerts and recommendations to the production team, each one of those getting help during the day, which material to use, which job to do first, when is it time for tool maintenance, and alike. And by synchronizing all of the players on the production floor, the factory is streamlined, more robust, and much faster reacting to changes. So how do we do this? And again, from our experience, there are typically, let's say, three main phases. First is collecting data, and we'll talk about that. And we really want to talk about the relevant data. Then we want to put the data to use, predictions, recommendations. And then the goal is really to achieve production KPIs. We're not doing this, for the sake of technology. We're doing this for the sake of improving manufacturing, improve efficiency, reduce costs, and alike. But before any of this, I want to state the obvious. Before you solve the problem, before you deploy the technology, you really need a clear problem statement. If anything, today, that's one of our most important messages. We see a lot of companies going after the technology, but not really sure what they're looking to solve or what kind of business KPIs they're looking to achieve. This is a big source for failure, where the inability to get management buy-in or the team, the staff buy-in, inability to demonstrate the value or get the budget. So whatever it is you're after, irrespective of technology, these are the problems you want to solve. Are you looking to meet rate? Are you looking to reduce costs? Are you looking to streamline your inventories? Whatever it is, these are the problems you want to solve, and this is where you start. Now, once you've defined the problem, certainly you need to model the solution. And whatever the solution is, whether it's scheduling or materials management or tooling maintenance, it needs data. And the first step is really getting the data. Now, the data will come today from three main sources. Your enterprise systems, they're deployed. Your PLM, your ERP, or MES, it has a lot of data. Most of it is not used in full. Machines and sensors produce a lot of data. We want to get it, we want to capture it, we want to put it to use. And of course, our team, our operators, they can give us a lot of insights, they see things, they can report things. But the key here is that there's so much data. We need to make sure we're getting the right data and only that. The data acquisition has to be very effective and surgical for the project to succeed. Otherwise, we'll just drown in the swamp of data collection and never quite reach the problem we want to solve, which was defined on the first get-go. So we have the data. And then what do you do with it? And we want to put the data in context. Context awareness is an AI term, but really it's just in plain English. Data alone is insufficient. If the sensor tells us that the tool is here in this room, well, is it good or is it bad? It depends, right? Depends where this tool needs to be. And how do we define that? Well, with the bill of process, the bill of material, the maintenance schedule, and so forth. So the data alone is not enough. And how do we get this context? We get it from the systems, from the sensors. ERP, PLM typically tells us what needs to happen. The MES, the sensors, tells us what is happening. People further report on top of that. And the more data we have, the richer the context. And then we can make a better foundation for the coming decisions and recommendations. But all in all, we want to reach stage 3. We have business problems to solve, and we want to solve them. And here I mean really operational problems. We need to increase our rates. We need to reduce our costs. We need to improve our OE. Whatever it may be, the data for the sake of data is not really interesting. So here's a framework we work by and really would like to recommend, both from a methodical point of view, but also from a technology point of view. The data, you see it on the bottom, comes from multiple sources. The relevant data is pulled in to a single place. We're really breaking the silos, putting everything in one place. Mitch will talk about it. SAP data, CAD data, machine data, all flowing into one place. Now we, the software, know what's going on, and the AI can start kicking in. Well, what's going to happen? We start making predictions. And if something wrong is going to happen, we want to raise the alert. And I'll give some examples later. This job is going to be late. This material will expire too soon. This tool is going to create a quality issue. And then, what do you do about it? So instead of just telling a supervisor, an operator, that they have a problem or about to have one, we really want to solve it. So instead of just saying, this tool is going to create a problem, let's recommend maintenance. Instead of just saying, this material will expire too soon, let's reallocate material. And of course, as the day ensues and more decisions are made, this cycle continues, and this needs to happen in real time so that everyone is synchronized. Everyone makes the right decision at the right time. Whether these are around scheduling, materials optimization, tooling management, and alike, all of these problems follow this same framework. So here real quick are a couple of examples, and this is part of the Middle River story. We're tracking raw materials, we're tracking the kits, we're managing the shelf life. So we know how much time a material has, but we can also start predicting how much time production will take. And if production is going to take longer than expected, that's warning number 1. But if the material is not going to have sufficient shelf life, we're not only going to be late, we're going to produce a defective part. That's exactly the 2 things we're trying to stop. So here you see how the user is warned that the problem is happening. And of course, we need to resolve it. Either expedite this job, send it back to the freezer, or simply reallocate the materials. And what you see here is the pick list, okay, where the operators every day, based on the full job due, the material inventory, predicted shelf life, material status, and everything combined, we are developing the list. What do you need to pick today? Which materials, from which freezer, for which job? And this is on a tablet or a PC that the user is using on a daily basis, or if they need to pull something urgently, they use that as well. So here we're basically recommending helping the user to pick what they want, and certainly they can pick anything else, and we have full traceability of that. The second package deployed already at Middle River is for optimized cut planning. And what you see on the top here is the traditional nesting approach, where you take part by part and you nest it separately. But the opportunity here is in the bigger picture. If we have the full production plan from ERP, SAP, and Middle River's case, if we have the full data on inventories, material sizes, batches, shelf life, this is within our application. If we have the geometries from the PLM and CAD side, we can start making more interesting decisions like mixing jobs, utilizing remnants, certainly increase the yields, reduce the setup, while maintaining the full traceability. So this is part of the implementation at Middle River, and certainly on top of the Eastman machines, fully integrated, and so forth. And as these supplies flow downstream, we have full traceability from materials to plies to kits to parts as they're being laid up on the lasers with Vertec all the way through the finished product. So this traceability is fundamentally not only for quality or regulation, but certainly also for operational use to expedite or accelerate recall scenarios, and also, frankly, for our AI. This is the foundation for our learning processes. As we collect more and more historical data, we can make our own insights for the users on the production floor. Part of Middle River's journey is to potentially extend this to the supplier of the prepreg, and have this traceability from the supplier over transportation and onto their production floor. Mitch will address that as well. Mitch will also talk about the deployment methodology. Here we've really come with a lot of industry experience. For us, this is a partnership approach, dealing with the customer, the project team on a daily basis, understanding the needs, defining the interfaces, deploying the system very gradually, working with the team, with the users, to ensure that they're adopting the system, and frankly, gradual deployment and open communication. That's the secret sauce. Whether this takes several weeks or extends in multiple phases over several months, this is the key to the success. And make sure really that the business achieves those core KPIs that trigger the project. If you remember Einstein in the beginning here of the presentation, we're looking to improve quality or yield or both. So how are we doing? How are we achieving these goals? And if not, how do we fine-tune the system? And the last thing I want to cover here is really this digital journey should never stop. It's a gradual approach, but we also want to really push the envelope. When we look at two applications, two AI applications, we want to compare which one is better than the other. And our approach is to compare them across two axes. One is the level of intelligence. How good are the recommendations or decisions or the optimization made by the software? And the second axis is the level of automation. Simply put, the greater the automation, the greater the intelligence, the greater the business value. So this is not an academic question. This is a question of superior business value and how a business process, production, Middle River, can gain more. Mitch will talk about their gradual approach, but also about their future plans. And their goal is really to push the envelope, increase automation through more integration, through the Eastmans, to SAP, to Vertec, increase the implementation of decision-making through production planning or tooling management and the like. But certainly if you look at these four quadrants, you want to be in the green area, highly automated, highly intelligent. Smart software that needs a lot of clicking, a lot of manual intervention can help, but it's highly dependent on the user, and that's a drawback. Certainly high automation and poor decisions is where you don't want to be. And then, yes, there are very good software that are not automatic nor intelligent, but these are not AI, but they're certainly very useful. Excel or the PowerPoint that we're using today are clearly in that category. Very good software, but not AI. So when you come and evaluate AI software, look for the greater level of automation and the value created by smarter decisions. So let me pause here and turn it over to Mitch. And thanks again, everyone, for joining. And we'll be back later for the Q&A.
All right, thank you, Avner. Let me share here. Okay, so I'm going to talk a little bit about one of our digital strategies here. And this is a part of our total strategy, but it's really around how we're going to handle the raw materials coming into the factory, how we process them, and how we ultimately get them onto the product. And the intent is to take that part of it and understand where we can drive more efficiency into it, cost out of it, and ultimately have a package that is very robust and repeatable and trustworthy. So get a little background about us. So we're a global supplier of Nacelle systems and aerostructures. So we've been here over 90 years. We were founded by Glenn L. Martin back in the 1920s when he moved from the Midwest out east. And that was primarily so he could launch his seaplanes into the bay. So that's our factory. We're still in the same building. And so if you can imagine, there's an awful lot of history and within the facility and our workforce. And over the last 5 years or so, we've really tried to move into more driving more digital and automation into our factory. And it's for several reasons. First is, of course, to keep up to date and because there's a certain amount of value you can drive from it. But also it is definitely the future of our industry. And for us, it's important to not only be active in it, but also be stewards of it. So you can see we have a product line. We've been in business for a long time. And this is kind of what we're doing with Plataine. So we kind of identified that our material handling system was not very modern. We have planning and we do Excel and do like various methods, but it wasn't really a smart system. So the intent was that we would bring in a new system that would manage all of that part of it for us. All of our perishable goods, optimize what materials we're using, make sure that we don't have trapped inventory somewhere. So there's that side of it, but also is to automate how we do nesting, ply cutting, kitting, things that we have been doing for a long time, but I would just say that we were not as efficient as we could be. And then ultimately is to introduce some AI into our system to help us predict our business and to kind of model going forward and to help us understand what's the most optimized way to operate. So we partnered with Plataine. And like some of the reasons is we've had some previous experience with them that was good with tracking. We have our whole factory is set up with our RFID towers, so we can track all the tools through our different rooms. But we also wanted to use Plataine because now since we have this tracking system, we could also do more of a focused approach on just the software around raw materials. And then really it's around taking our standalone systems, which we had with Cloud and Majestic and Nacelle, and to integrate them and use Plataine as, I would say, as they're the gateway or the conduit to which all the data kind of moves in through and where we collect data from. As you can see, we moved from Oracle to SAP HANA. So we had quite a bit of system adjustments that we are lumping into one. But it really connected our operating system, our projection system, our engineering system, and fundamentally the cutting systems. So they all kind of integrated together and allows us to kind of look at all those systems as a whole and then do better planning and understand the most optimized way to produce product and to cut material and kind of manage material. So what's the scope? So just in raw materials and ply cutting. So we're not a huge business, but we process about 3.5 million square foot per year. And it's about $25 million or more. And on a monthly basis, for all the different products that are running through here, it's about 1,200 kits per month. And a kit is basically each part number and all the different plies that have to go into it. So it's enough where if we can save 5-10% in here, there's clearly definite rewards that we can get off of it. So the original plan was we bought new machines and we were going to take a year and we were going to refit, install the equipment, develop the system with Plataine and integrate it and have a really nice transition. At the end of it, we would have this system set up and it's outside of our current system, and you would trial run it and we would make sure that we were happy and do run a rate and all the things that you like to do before you go to production on something. Unfortunately, the reality is that that often isn't the case. So we went from a 12-month to a 6-month. We launched right into it. We were not able to integrate Plataine into the system right away. And we had to transition our ERP, MRP system at the same time. So all of this was happening. And what we did is we kind of pivoted to a parallel path and we integrated incrementally over time. It worked out pretty well for us. I'm not going to say that there wasn't some grief involved in that, but overall, it was a pretty good transition from the old system to the new system and bringing in that software package. I think one thing that we come across is that plans rarely go as planned, and Plataine was easy to work with. My team did a great job. And being flexible and understanding and being able to pivot on the fly, I think those are all things, especially in this new digital world that we're trying to bring in. You kind of have to do that. It's the only way to really make it successful. And sometimes you don't get always what you want, but you certainly get what you need. the other key to this was that we spent a considerable amount of time understanding our problem. Like Avner is well aware, I sent him a very lengthy document, and it was really around how we currently do business and how we want to do business in the future. And by having a clear understanding of the processes that we want to automate, how we want things to connect and talk to each other, I think having that mapped out is really helpful, because you can always go back to that and understand, are we getting what we want out of the process? And is the software doing what we want it to actually do? And then, what you find is that there's things that are more important than other things as you get going, and then you kind of add features to it as you go along. It's actually a pretty good process. It actually, I was a little concerned. I mean, I'm not a digital person. I come from the world before cell phones, so I had a little bit of concern, but it actually was a pretty nice transition. So where are we at today? So we're pretty well integrated. There is some upstream work we have to do, and we have to do some other pieces of it. But overall, from the data we've collected, we've got about a 5% increase in our efficiency. So that's a pretty good number. We're managing all of our raw materials through the system. All of our nests, called markers, they're being generated within Plataine. It pulls data from our engineering. It does the dynamic nesting for us. So it's a clean transition from the engineering data down to the actual Eastman cutters. And honestly, as soon as we launched it, we started to see that we were getting some benefits from it. Better yields, just better understanding of our inventory, where it's going, how to use it. What you find is you end up with a lot of partial rolls. So the system's great at telling us, hey, go use these partial rolls and you'll make these markers. It'll be the best use. Those rolls in the past, we would perhaps not utilize them to their best, or we would chew them down to a point where we couldn't use them. We had to throw them out. So it worked pretty well. The other thing is operators. So can you imagine, we have a lot of operators who've been here 30, 40 years. And while they're readily will accept a new cell phone, they don't necessarily accept a new digital system at work. So I think one thing that we spent a lot of time is to make sure that the operators, we went to them and talked to them and got their input, because you have to have buy-in in the system. And I think that's one of the keys to be successful, is that you can, as engineers, we can come up with things and we can put things together and we can try to make them work. But at the end of the day, the operators have to accept them. They have to be something they can use. They have to understand the value and why. I think when you do that, it ends up being a much more successful introduction to the plant. And we've used this same approach on almost all the projects that we do here around us. So it's been great. I think that Plataine's ability to develop on the fly for us, we certainly have had there's issues. Data transfer, while it on the surface seems like it should be no problem, there's always nuances, especially when you're coming out of FiberSim into Plataine software, back out to Eastman, and understanding where label pointers are, what's on the label, things like that. There's just a lot of work that goes into making sure that transition is clean, and it actually went pretty well. I mean, certainly had some hiccups, but there were nothing that couldn't be resolved, in a short order time. And based on that, we're going to go forward. We're going to do some additional upstream work with our suppliers, automated moves through our SAP system. So you have to move and transact material, which that'll be automated. And fundamentally, at the end of it, is have an AI system that really handles all the materials coming in, all the quality steps of it, and really makes it so that the factory can operate really efficiently. And that's really what the end goal is so when you're done with this, you have a system. And don't get me, there is no end to it, right? You just continually develop and modify and add things. And it's just about, when you come down to it, you're grabbing those last few 2%, 3% here or there, but they add up. And that's really what it's about, is to be the most optimized factory that we can be. So that's our strategy. And so that's a place that we're going. So some of the things from lessons learned, I kind of mentioned some of these. Spend as much time as you need to understand what the production needs are and exactly what your problem is. I do think that is something that it's really easy to be caught up in the desire to put something into the factory. This ready, shoot, aim is not a good approach. So we tend to spend not a lot of time, but an appropriate amount of time that we convince ourselves that we've fully defined the problem that we're trying to solve or the areas that we're trying to go after. Engage the operators. They are the people that have to do the work. And if you don't engage them from the beginning, it can be difficult to mandate down changes down to them. And the value you get out of it, it is directly proportional to the buy-in you get from your operators, from your engineering team, from the production team. We've seen this several times on other programs, in other projects, and it is just crucial. So no system is perfect, and that's okay. But failure is not always the worst thing. It certainly helps you learn and tells you where you need to pivot and to go forward. And accept the pivot. It's important that even senior leadership understands it. There's nothing that's going to be a perfect transition. It's just not the way things work. But being able to pivot in smart manners and being successful in it, that's the real sauce that makes it work. So that's where we're at. Thank you so much.
Avner, is that the end of the presentation for today, you guys?
Yes, that's the end of mine.
Okay, that's perfect. Thank you. That was great. I am going to get us started with some questions, and then I would encourage our audience, please do enter questions in the Q&A panel on the right. Ask any details, and we'll see what we can come up with for you. First of all, to Mitch, how much time did it take you to deploy this solution in the cutting and the kitting?
So I think we started, I'd say, putting data into the system within probably 3 to 4 months when we kicked it off with Plataine. I think we started putting data in there at about that time period. And full deployment, I would say probably 6 to 8 months before I say we were fully deployed. Now, that means that we're kind of using it in production or making production decisions off of it. Of course, there's modules and there's things that we have to do before we do the full upstream and the downstream integration. But I consider deployed is that we're using the system or we're making production choices from it.
What challenges has the dynamic nesting presented?
Nesting.
The dynamic nesting when you're doing the.
The dynamic nesting. So we have the cut collect system from Eastman on our machines. So that system allows us to nest multiple parts and sort them without having to worry about mixing up plies. The dynamic nesting has been a great feature. In the past, we were I'd call static nests for each part number, and while that system's fine, I mean static nests are okay. You just can lose some efficiency on it. The dynamic nesting really helps you. It actually lets you use your day more efficiently, right? We can make longer markers, longer nests, and utilize our workforce in a much more efficient manner. It is absolutely a more efficient method for cutting.
Does it change how you staff that part of the operation? Does it change how you handle that part of the operation?
You mean from operator staffing point of view?
Yeah.
Well, no, I mean, so you have people working in the room whether they're doing work or not, right? You don't have somebody work the job for 2 hours and go somewhere else. At least we don't typically do do that. If there's no work for a day, we can move them around. But what it does do is that the real trick is that once you know your weekly cut plan and you have your markers, you have a pretty good understanding of the time it takes and the resources you need. So what you can do, there are certainly times when the room is not fully at capacity. So there are times you say, okay, we're going to cut Monday through Thursday, Friday, we're going to redeploy people somewhere else. It's not very often. I think it's only happened once or twice. It was during startup, but now we've got enough volume going through it that we're pretty well full up. And at the end of the day, what we want is 3 full shifts, right? 24 hours a day, cutting plies, so that we get full utilization of the operators and their time.
What kind of
Ginger?
tangible ROI did MRAS see when you digitalized for material planning?
So the out of the gate ROI right now that we've been documenting is anywhere between 5 and 10% material usage. So if you dollarize that, let's say you look at, and so some of the materials are the most expensive materials. So lightning strike materials, film adhesives, they're the priciest materials that we have. So optimizing those nests, I mean, lightning strikes can be 15 or like more dollars per square foot. So those materials, if you optimize them, you can pull, if you're pulling 5% out and you're processing $25 million a year, it's a pretty good ROI for an investment that wasn't that extreme, to be honest with you. It wasn't like we spent millions and millions and millions of dollars on this. There certainly is an investment in it, don't get me wrong, but that payoff is way, way, way worth the investment.
With your nesting implementation, do your cut kits stay out at room temperature, or do you assemble completed or incomplete kits and then put them back into cold storage?
It depends. If we have demand on the floor for a particular product, anybody who's in a composite shop know that sometimes product needs to have rework done to it, and you have to pull ahead in your production schedule. So if we have to do that, we can insert a kit, re-nest, make the marker, make the kit, send them right directly to the station. For what I would call our buffer kits, which we try to keep in the freezer, those of course get kitted up when we put them in racks and put them in the freezer. So it just depends on what the need is for the day. I think that flexibility in the system is definitely key, because you just never know. The best plans, right? You think you got it and you think you have your whole week set up, and then all of a sudden you got to recut a whole new set of kits for something that you didn't plan on it. So, but it's about having, I mean, the system needs to be flexible enough to handle that. So, and it does. So for us, I guess maybe the answer is we have both situations. Ideally we try to cut and then freeze for about a week or so, but it doesn't necessarily mean that that's the case.
What?
Ginger? Excuse me, can you hear me?
Yeah, I can.
Oh, great. Yeah. First of all, just combining the last set of comments by Mitch, it's really amazing to see, the amazing job that the team is doing there. It's a very complicated environment. We see a lot of composite shops, and this is, as complex as it gets. So just, the ability to put kits back in the freezer, but again, you need to maintain the shelf life. And these kits came from some material which also had shelf life, and then you pull them back out. So all of this is monitored. And this key of flexibility that Mitch has mentioned, you have a plan for the week, but it's surely, sooner or later starts falling apart. So the ability of Middle River to deal with that while ramping up, while dealing with defects or any other just, stuff that happens is, I think, a key part of their success in this project.
Okay, one of the questions talks about defects. It asks, is the dynamic nesting able to re-nest plies around known defects on the material roll?
Okay, well, I'll take that, Mitch. This is actually a new release by Plataine. So Middle River are not yet using that, but they are about to. So this was a recent capability that was released, I believe, about a month ago by Plataine. The key here is to get the defect data from the supplier, the location and shape of the defect, and then, yes, dynamically nest around it. So of course that increases the yields of the material, but also really saves a lot of hassle and setup. Get the roll off, get it back on, cut the defective area or not. Or so simply we just nest around it, and then the process as a whole is streamlined. So Mitch, you've yet to see this, but it's coming soon your way.
Yeah, so that'll be a good addition to the software package. I think for kind of the way that we handle it right now, Ginger, is that we cut applies. We don't cut around defects. So that's not true. The areas in the roll that are marked with defect tags, we do cut through them. And sometimes what you'll find is that the defect being marked doesn't necessarily interfere with all the plies you've cut. It does add time to the process, and that now we do look at every ply as it's coming off anyways to make sure that there's no issues. But for those that do have the defect in them, you got to recut them. I think at the end of the day, what we want is what Avner has, is that you're going to have roll material coming in, and it's going to say, when you're on this linear foot to this linear foot on the roll, we're going to quarantine that off and say we're not going to cut any plies in there. You do lose yield, but the reality is on those rolls, those defect areas, you typically are not counting them as part of the roll anyways. So it's not, you shouldn't be losing, I would say, cost out of the process. However, it would be ideal to have that so that when the markers come through, you can pick them up. Says, hey, listen, we're gonna that 2 or 3 linear feet or 5 linear feet, we're not going to actually cut anything in there. But right now we cut them and we sort them out and we recut as we need.
I think this question, I'm going to ask it and then I'm going to see if I can rephrase it. How did you manage kitting post the implementation of Plataine for ply cutting, since now many parts are being cut simultaneously? So that was one of the things I saw when I was there touring, and we talked about briefly, is that to me, that gets really complex. I mean, we saw on your picture, you have all these different colors and those are different plies for different parts. You just got a lot more complex. How do you deal with that on the back end of it?
So I would like to tell you that it's a really elegant, fantastic kitting process, but the reality is it's just a lot of tables. The machines put out a lot of plies. They're conveyor type systems. They'll cut. And you're right. The kitting process is always the most difficult side of things. For a couple of reasons. It's not like we just take a pile of plies, lay them out, and just roll them up. It's really pretty bad form to be manufacturing in that way. For small parts, you can get that way, but I mean, some of our ply kits are 500-600 plies, right? And there's some parts are very large, so we split them up into different regions, and it's important to sort them in the right way. But the answer is that it's table time, and really it's around, to make that the most efficient way to do it, is that as the material comes off, I would call it, we do a rough sort, and then you do a fine sort when you're building putting your kit together, and having a clear kit plan. I'd call it a very clear sorting and kitting plan for the operator to follow for every part number. It's what makes it work, and it's pretty good. We're not 100% there, but the team's made great progress on it.
And I think that was something you said you're looking at more automation in the future on that end, probably.
For sure. I mean, we're going to try to automate the things that make sense, and I think that's one of them that definitely does.
We have a question. What was your biggest challenge when you moved from standalone systems to a smart material manufacturing ecosystem where you're putting all the different software together?
I would say actually it's getting the data from the MRP ERP systems into the Plataine software, making that data transfer in so that it's accurate and manageable. It's important to understand the fields and what's the relevant data that you need to have. I think that was one challenge. I think we've made great progress in it and going pretty well right now. Our material supplier, we're working with them so that is even a seamless approach or a process. The other actual challenge for us is that we went from a very old nesting software package to a completely brand new one, and making the transition, that communication out of Fabric Optimizer into the Eastman machines. And I'll be honest with you, labeling is a really key function, right? I mean, plies are only as good as the label on them. Otherwise, you don't know what to do with them. And we spent quite a bit of time creating the right labels for us. It took a little bit, but they're good now. So we're happy with them. And we're going to move on to, I'd say, advanced labeling methodologies down the road. So that'll make it even more efficient and more friendly.
We have a question about when you went with the dynamic nesting, so you have these longer kit pieces. Did that change your material usage? And I assume the Plataine system would then deal with that because you have these longer markers, right, that you're pulling out.
I'm not exactly. So I guess maybe I'll rephrase it this way. So on a static table, so you make all your nests to fit on your static table. when you go to dynamic nesting and a conveyance type cutting system, right? Fundamentally your markers can be as long as you want. You might have to feed up several rolls to satisfy the need for that marker, but there's nothing that would stop you from doing that. It didn't change. Like, apply shapes are generally restricted on geometry on what an operator can hand lay up, right? I mean, there's just some plies. We will purposefully not cut really huge plies. You just can't lay them up. I mean, it's just really cumbersome. I don't know if you've ever done it, but it's just brutal. So we don't it doesn't change the ply shapes. It just makes the nest long. But I don't think that is much of an issue, to be honest with you. At least from what we've experienced in our cutting.
With your operators, what kind of feedback did you get from them? How was it received when you started going through this whole process?
So I would say there's two buckets of the operators. I'd call it, there's the production control side, and then there's the actual cutting and kitting side of things. The production control, I think, like in anybody else, you get used to a system that you're used to, and it changes as always can be difficult. I think when you have to explain and get them to buy in and understand the value of what you're doing. It's not, and sometimes it's not easily communicated, but I think when you can successfully do that, that side of it becomes understandable to them. And the intent is, like, we're trying to make the business operate more efficiently and make your job be more efficient. We want our workers to feel like they're contributing and they're a part of the success of the business. And in order to do that, we need their buy-in. And so there's this PC side of it where they're moving materials in and out of freezers and bringing them in the room and things like that. And then there's the cutting side of it. And the cutting side of it, I think those operators, they were pretty readily open to bringing us something new. I mean, it's you've been doing the same job on the same table for 30 years, right? And to see something new, a new system, and while it certainly can be maybe a little difficult to accept the change, or perhaps to really embrace the change, I find that most of them were like very open to it. They're happy to see new technology, happy to see where we're going forward, understand the value. I don't think we had a real big pushback from that side of things.
Ginger, if I may add here,
Yep.
I think you guys did also a great job just, removing a lot of paperwork and continuing to do so. And I think, most people actually appreciate that a great deal.
Yes. One thing that people don't, I mean, and this myself included, like, our factory still is a predominantly paper type factory. So, it's hard to appreciate not having to write a pile of information every single time you cut a kit, cut a ply, pull out a roll, do the out time label. Having a system that does that work for you and just spits out a label is quite awesome. I've done a lot of it, so I can tell you it's definitely a great advantage.
And then the idea is to use all of that information as you go forward, right?
Oh yeah, absolutely.
Does a Plataine solution, I mean, Middle River, Mitch, you say you're not large, but you're pretty large as a business. Is this a solution that even a smaller company could deploy?
I think that if you have a high part count going through your factory, or a small factory or a large factory, even the small factories or the smaller businesses, right? If they have a high part count, and I think there is a key to it that makes it really successful here. And we use basically the same material systems for almost everything. We harmonized all of our new programs into one material stream, more or less. So it really allows you to optimize your material usage, just because you're not having to pull 12 different prepregs and shove them through the machine because you have 12 different customers with different specs, right? That's the only thing that I think for a smaller business, it'd be more difficult as far as doing production. But at the same time, the system probably adds more value
It would help you manage.
because you're managing so many different materials. Yeah, the ability to manage all those different materials. I think even a small business, if you have a high part, I mean, if you're building just one part over and over, or just building small part counts, I think there's efficiencies to be pulled out of every business. You know, I think everybody has to do their own calculation on the investment and the ROI on that. So,
Do you have anything you want to say, Avner?
No, I'm just, what we're seeing again in the market, we're seeing very small suppliers up to very large and complex organizations, and some of them actually running the system across multiple sites. But even the smaller ones, and perhaps Ginger, you have your insights here, in today's world, they can't really afford to be supplying a single part to a single program. So the complexities are inevitable. And typically, with the smaller suppliers, they don't always have the IT staff to deal with a lot of this. So simplifying the process, digitization goes a long way, frankly, on smaller, medium-sized, or very large operations.
I know, Mitch, one of the things when we were walking the floor, you know, one of the things you guys have had to deal with was like the 777X program got a kind of stop put on it while Boeing worked out the MAX and some other issues it had. And then in that downtime, you had to pick up other business. Does having, you know, this new setup where you've got Plataine and you've got a more digital system with your materials, does that help when you have those kind of disruptions? Does it help you with the flexibility?
Yeah, because I think, you know, when it's integrated into your build plan and you're pushing your build plan schedule through it, right? It, as that changes or stops or it goes away or it does whatever, it does two things. Is that any material, right? Look, if you're buying materials now today, like there's pretty good lead times on everything, right? So you may have a freezer full of stuff and then all of a sudden you can't use it. I think what's really grateful about this system is that now you can, as soon as that hiccup occurs or there's a delay or the schedule shifts or any of the other things that we can't control on the part side of things, it really lets the business know, hey, how much risk do you have sitting out there in inventory? I mean, there's none of the stuff we buy is inexpensive, you know, on any program. So I think that value is it's important, right? It's important to be able to communicate what you have and what the potential risks are as production schedules change, push outs. I mean, it doesn't happen just on like 777X, right? I mean, COVID had big impacts on the single aisle market and, you know, some of the other markets, and you know, we supply to like Comac, right? So in that Comac, that market's up and down. So I think it's just helpful, and that now you can always have a real understanding of what you have, what you plan on buying, how much you bought, where is it at, how much inventory, and then are you able to actually consume it in the most appropriate manner. So I think it has value whether it's you're at rate and you're just chugging along, or when you have changes in the schedule.
So a question about you guys going forward, and like you said, you have the RFID towers, and you're looking at different tags. I mean, that's one of your goals going forward, is to then start tracking not just materials, but where the parts and the tools are going to be.
So we've done some of that. I think that we have done that. I think that that in the far as in the future where that goes, the system's there. We know it works. We know we can do that process. We have all of our tools tagged. All of our kits are even tagged for that matter. I think the question will be is what value can we drive out of production or drive in out of the system and efficiency out of the system. And when we deploy it again in a full active mode, what's a measurable way to make sure that we're getting the efficiency through the factory? I think it's good to know where things are at. Don't get me wrong. However, it's about flow, right? Composite shops are flow-driven events. We're paced by autoclaves, right? Autoclaves are the takt time driver, right? It goes in the autoclave and then you don't get to see it again for a while. And but understanding that flow in and out of them, and you know, be honest with you, as a sustainability leader here, autoclave usage is a huge driver of energy. So we of course we optimize our clave loads as much as we can, but in order to do that, you need a system that understands part flow, where it's going, what can go together, how does it go together, and how do you optimize it, and what clave does it go in. So when I look at part movement going forward, that's kind of the things where we'll be looking at is to try to optimize the usage of all the equipment that you've already.
Yeah, I was going to ask you about that. I mean, when you and I were walking the floor and looking at the factory, it's so massive and it was built a long time ago. So the challenge for sustainability is pretty significant. It's not like you get a brand new, highly insulated building. I mean, you're dealing with what you have inherited.
Yeah, and we don't own it, right? We rent it.
Yeah.
So it's been a rent for a long time, but regardless, we don't actually own the facility. And as being 90 years old, like they didn't design them to put solar panels on the roofs.
Right.
Right. It's not serviceable. It is definitely a challenge. But every problem, once you define it and spend enough time on it, you'll figure out some sort of solution. So we're getting there.
Ginger, it's Avner here. If I could just connect a couple of dots that Mitch mentioned earlier. So, the autoclave being such a critical asset and to an extent a bottleneck. So yes, we want to plan them better. And that's one of the paths forward that Middle River is looking at, in terms of, pushing the envelope. And certainly to do that better, it's very useful to know where stuff is, hence the evaluation and gradual deployment of RFID. But the third element, and Mitch mentioned it earlier, is the integration to the Vertex lasers.
Oh, that's right.
We know the progress of the layup for any given part on any given tool. We have very clear visibility, for that last station right before autoclave. And at that point, you can finalize your autoclave planning, knowing what's making this next bus and what needs to wait for the next bus, and perhaps you need to delay the bus 10 minutes. So what you see here is how we aggregate different data sources, sensor data, ERP data, and data off the projectors to complete the picture. And then you can make a very good decision and recommendation on the autoclave planning. Lacking any of these is not a disaster. You just are making a less informed decision. So as we gradually push the envelope here, we're adding more and more data points, digital data points, to create a far more informed decision, in this example for autoclave planning.
Yeah, that's a really great point, because if you think about it, COVID's made it really obvious that we don't understand our supply chains as well as we thought we did, and we don't have it dialed in as much as we thought we did. And what you're really doing there at MRAS is you're giving visibility to your whole supply chain inside, from when a material walks through the door to when you get a part out the other end. You're trying to add more and more visibility, right?
Yeah, I mean, for sure, that's the whole goal, right? I mean, in a perfect world, the whole system talks to each other, and instead of having to run around and figure out where things are at, what's going to close out, what's going to final bag, what tool strings going where, and how do we pack them in, right? Ideally, the system says, hey, listen, this is how your day is gone or your week is gone. This is how you progress to what you're supposed to be building. And if this is the correct load times. These parts should all be done. They'll be going to the clave. You load them like this, right? That's the final optimized solution for a production facility, at least for autoclave batch style processing.
But not only that, so once you would get to that point, then that data would then let your machining cells know what's coming.
Oh yeah, absolutely.
You have a lot of perf drilling you do for these acoustic panels, those, and you only have 2 of those cells running that whole plant, which is crazy. But you would know what's coming into those.
Yep, it's all flow. It's understanding flow and applying lean principles to it, right? So you understand how to batch things up in the right process. So yeah.
And Ginger, from our end, this, and Mitch, I'm right with you on the vision. We want to get all the data from everywhere. The problem is it just becomes too much for any one of us human beings to digest it all fast enough. And certainly when you have multiple people needing to make multiple decisions in different areas of the plant. So here really is where the technology helps. And this is really about creating the man-machine team so that the overall operation is smoother, more efficient. This is exactly as Mitch said, that's where Middle River is going, and I think it's amazing.
I think it's so nice to hear, Mitch talk about it, because a lot of times when we talk about it in CW and we look at articles, you get this shiny digital factory, and it just seems like, well, where do you start? And yeah, how would you ever get there? And I think it's lovely to go to a real company that has a real history. It has a real footprint of what it does on a day in, day out basis, and has to deal with real problems. And we're watching you walk through it. It doesn't all happen overnight. It happens over time. All right, guys. Well, I want to thank, again, our Presenters today, Avner Ben-Bassat from Plataine and Mitchell Smith from Middle River Aerostructure Systems. We really appreciate it. We appreciate all the questions and everybody's participation today. We encourage you to reach out to both of them to learn more. And we really hope to see all of you again on the next Composites World webinar. Have a great day, everybody.
Thank you.